All right, so today's class we're looking at ratio. Well, the unit is ratio rate in percent. Today we're looking at ratios. So we just started by watching this video here, the Math Antics video on ratios and rates. All right, so just to review that, we can write ratios as a comparison. All right, so we're comparing two numbers which have similar units of measure. So in this example, we're told that 4 out of 5 dentists recommend sugarless gum. So we can write this as a ratio. We can write it in 3 different ways. So we have the ratio method, 4 to 5. 4 out of 5 as a fraction, also as an ordered pair notation, 4, 5. Right, let's take a look at this example. Write a ratio describing the relationship between 3 dimes and 4 quarters using all 3 methods that we described above. But first, before we can do that, we have to make sure that all the units of measure are the same. So we have to make sure that we write them into cents. So make sure that we have the same unit of measure. So we are going to make sure it's all in cents. All right, so 30 cents and then 100 cents. All right, so when we write this now, we can write it as our ratio method. So it would be 30 to 100. Okay, that's our ratio method. We can write it as 30 out of 100. That would be our fraction method. And we could also do the ordered pair notation, right? So we could go 30, 100. All right, that would be our ordered pair notation. All right, and keep in mind here that we can reduce. All right, we'll leave it as is for this example, but keep in mind that we are able to reduce. All right, let's give you a couple here to try. So write each in a ratio in the 3 different ways. So 17 people in a class of 25 have brown hair. In the second example, the second question, the number of vowels to the number of consonants. Okay, give that a try. All right, so for the first one, ratio method 17 to 25. Okay, the 2 dots, we just say 2. So like we would just say 17 to 25 when we read that out loud. Fraction method, we would just write 17 out of 25. And then if we did that in the ordered pair notation, we could write it like this. All right, give the second one a try. The number of vowels to the number of consonants. All right, so for the number of vowels to the number of consonants, it depends if you included Y as a vowel. Okay, so if you didn't, if you just included A, E, I, O, U, that's 5 vowels. Okay, and then consonants, you take 26 minus 5, which is 21. So it would be 5 to 21, which we would then write as 5 over 21 or 5, 21. Those are the 3 methods. This is the ratio method. But sometimes we can include Y, so that would make it 6 vowels. So that would be 6 to 20. All right, that's if we're including the Y. All right, so if we put that in fraction form, 6 over 20, we can reduce that. So don't forget to reduce that. That would reduce to 3 over 10. All right, and this could also be written as 3 to 10 as the ratio method. All right, so we could have 6, let's go back, 6, 20, which is also written as 3, 10. All right, either way. Okay, so next we're just looking at equivalent ratios, so kind of similar to what we just saw in the last example. Ratios are equivalent if they make the same comparison. So you can make equivalent ratios by either multiplying or dividing both numbers of the ratio by the same number. So just similarly to what we were doing when we were looking at equivalent fractions. All right, no difference. All right, so here we have 2 fractions. Here we have it written as a ratio method. All right, we just have to make equivalent ratios for each of the following. So let's say for the first one, let's just say we're going to multiply by 2. So you have to multiply the top and the bottom by 2. All right, that would give me 10 over 14. All right, so that means we can write it as a ratio as well. 5 to 7 is equal to 10 to 14. Okay, 12 over 15. Let's reduce this one. We can divide the top and bottom by 3. Just going to show that here. I'm dividing by 3. All right, so the equivalent fraction would just be 4 over 5. All right, but in our ratio method, we could write that as 12 to 15, which is the same thing as 4 to 5. All right, here we have it already written as a ratio method. So let's just multiply, just for an example, we can just multiply by 5, but you can multiply by anything you want. All right, so that would give me 40. 8 times 5 is 40, and 9 times 5 is 45. Okay, so 40 to 45. All right, and if we had written that as a fraction, 8 over 9 is equal to 40 over 45. All right, so very similar to when we were working with fractions. All right, next we're just going to look at a method called cross multiplication. So in order to determine if ratios are equivalent, we can simply cross multiply. If the products are equal, the fractions or ratios are equivalent. So let's say we have these two, 3 over 5 and 12 over 20. Are they equivalent ratios? So one method is called cross multiplication. We're just going to multiply 3 times 20, which is 60, and 5 times 12, which is 60. All right, so 60 and 60, that's equal. So therefore, the two fractions are equivalent. So yes, they are equivalent. Okay, so that's a method called cross multiplication. And we can use this method of cross multiplication to figure out a missing part in a fraction or ratio question like these. All right, so sometimes you can just figure it out using our equivalent fraction method, but you can use the cross multiplication method. So with the cross multiplication method, you're going to multiply the two numbers that are diagonal to each other. So we're going to take 4 times 45, and then you're just going to divide by 15. Okay, so that's our cross multiplication method. Multiply the two numbers across or diagonal to each other and divide by the number that's by itself. So 4 times 45 divided by 15, and we get our answer is 12. All right, same thing here. I'm just going to set this up as a fraction. 7 over 9 equals 21 over x. So I'm going to multiply the two numbers diagonal to each other. So 9 times 21. And then I'm going to divide by 7. Okay, which gives me my answer of 27. You may have noticed you could have used just equivalent fractions as well. Like 21 divided by 3 gives you 7. A number divided by 3 would give you 9, which would be 27. All right, I'm going to give you guys these ones to try. All right, so solving all of these, we're going to use the cross multiplication method. All right, so we're going to multiply the two numbers that are diagonal from each other. So that's 18 times 100. So we're going to go 18 times 100. Then we're going to divide by the number that doesn't have a number diagonal to it. So we're going to divide by 30. Okay, so that's the method of cross multiplication. Multiply the two diagonal and then divide by the one that's not. So feel free to use a calculator here. 18 times 100 divide by 30 and you get your answer of 60. All right, so x here would be equal to 60. So here next, our x is down here. Okay, but again, the method's the same. You're going to multiply the two numbers that are diagonal to each other. So 30 times 45. and then we're going to divide by 5. And again, feel free to put that in your calculator. All right, so 30 times 45, divide that by 5, and we get our answer of 270. All right, and then our last one, our x is up here. So again, multiply the two numbers diagonal from each other. So 1 times 45, and then we're going to divide by 25. All right, and for this one, you would have gotten a decimal of 1.8. All right, so we'll stop here for today. Okay, so lastly, we're just looking at a ratio that has 3 numbers here. All right, so we have to solve for x. So look here for the pattern. So we have 5 going to 10. We have 7 going to 14. So this one's a simple one. A number multiplied by 2 will give me 12. So therefore, x will be equal to 6. All right, so that one was a simple one to find. Let's try one more. Okay, so last one here. So we have 7 to 5 to 2. It's equal to x to y to 10. All right, so how did we get from 2 to 10? We multiplied by 5. So therefore, 7 times 5 is 35. And then 5 times 5 is 25. And then we would have to 10. All right, so 7 to 5 to 2 is equal to 35 to 25 to 10. Now, this is where we will stop.